A very good morning to all of you. I cordially welcome you all for this applied thermodynamics course. So in the today's class, we are going to discuss about the steam generators. That is the second unit. We are able to discuss about the steam generators. So here, the contents to be dealt in the today's class here is introduction to the steam generators and classification of the boilers and low pressure boilers working principle, and similarly the Lancashire boiler working principle we have to deal in the today's class. And similarly each and every class is having the motivation, that is why we have to study this particular topic. So just you go through the motivation sentence. That is, it is very essential to know the classification of the boilers and the working principle of the Lancashire boiler while selecting a boiler for a given application, because the boilers are used very widely for the various applications. So whenever you are having the variety types of the boilers, so which boiler is basically suited for a given application, so that should be known to each one of you. So in the today's class we are able to classify the boilers and we are able to discuss about one of the important fire tube boiler, that is the Lancashire boiler, and how can you select a boiler for a given application. So that we are going to discuss here. And similarly, what is the outcome? What is the outcome of the today's class is, after completion of this particular lecture, so you should be able to classify the boilers and explain the working principle of a Lancashire boiler. So that is the outcome I'm expecting from all of you after listening the today's class. So basically here I have given, so how can you define a steam boiler or a generator? So how can you define this particular one? That is a steam boiler or the steam generator. So it is a closed vessel in which the water is basically heated and vaporized and converted into steam at a pressure higher than the atmospheric pressure. That is, what is the basic function of a steam boiler? So that is basically given here. A steam generator is a closed vessel in which the water is heated, vaporized and converted into the steam at a pressure higher than the atmospheric pressure. So here, what are the advantages of this particular the steam? So here I have written, so it is basically cheap and it can be produced everywhere, and it is a very clean source of the energy, and it is an odorless and a tasteless source of the heat energy, and it can be used repeatedly again and again, as well as first used for the power generation and then for the process heating applications. So here, what are the main applications of the steam? That is, why we have to generate the steam in the steam boiler, and actually where this particular steam is basically useful. So it is useful for the process heating, like the curing and drying applications in many industries like the sugar mills, textile mills and chemical industries, and almost in any process industry you require this particular steam. And also it is used for the power generation in the thermal power plant, because without steam we cannot produce any power in the thermal power plants. And because of having the larger heat content, the steam is basically using for all the types of the cooking items like the steamed rice and idlis. That is, whenever you are going to the main pilgrimage centers like Tirupati or Yadagirgutta or Vemulavada or Shirdi, so there they are using this particular steam for cooking the steamed rice, and similarly for dal and for the sambar and for the idlis. So they are using only this particular the steam. A lot of energy will be saved by using this particular the steam. And steam also can be used for the heating buildings and producing hot water in the winter seasons, and those who are living in the cold regions and in the cold countries, and especially the steam is basically useful for heating of the buildings and producing the hot water. And similarly, the steam also can be used for the creation of the vacuum, ejection of the gases and sterilization purpose. That is, just I have listed down only some few applications, and there are some more applications are there for the steam also. Now you can list the some more applications of this particular steam. And let us go to the next topic, that is the classification of the boilers. So that is, the boilers classification will be done on the various parameters. So the first one is according to the relative passage of water and the gases. So these are classified into the water tube boilers as well as the fire tube boilers. So in the water tube boilers, the water will flow through a small number of tubes which are surrounded by hot combustion gases. That is basically whenever you are having this particular the tubes, so in which the water is basically flowing inside this particular the tubes, followed by the flue gases are basically surrounded by this particular the tubes. So because of which the hot flue gases are basically giving up its heat to the water which is flowing inside the tubes, so that the water will be getting heated and it will be converted into the steam. So this is the working principle of the water tube boilers. So majority of the thermal power plants are basically using the water tube boilers only. The examples are Babcock and Wilcox boiler, Stirling boiler and Benson boiler, etc. Exactly reverse phenomena we are able to observe in the fire tube boiler. So in the fire tube boiler here, the flue gases are basically flowing inside this particular tubes and the water is basically surrounded to this particular the tubes. So that's why the heat exchange is basically taking place between the flue gases as well as between the water. So this is the working principle of the fire tube boiler. So the examples of the fire tube boiler are the Lancashire boiler, Cochrane boiler, locomotive boilers, etc. So in the today's class, we are able to discuss about the working principle of a Lancashire boiler. So it is the first classification, it is the first method. And the second classification is basically according to the water circulation arrangement. So according to the water circulation, the boilers are classified into, so that is the natural circulation and similarly the forced circulation. So here you can see that it is the natural circulation and here it is the forced circulation. So whenever the water is circulating automatically due to the density difference between the hot water and the cold water, then it is known as the natural circulation boilers. So the examples are the Babcock and Wilcox boiler, Lancashire boiler, locomotive boilers, etc. And coming to the second category is the forced circulation. That is, we are creating forcibly the circulation of the fluid flow. So in this particular one, we are able to have the Benson boiler, Lamont boiler, Wilcox boilers are examples of the forced circulation of the boiler. Next one, the classification is done according to the usage. So according to the usage, these are classified into the stationary boilers. That is, almost all thermal power plants are examples of the stationary boilers. And portable boilers, that is, these are the small units of the mobile boilers that are used for the temporary uses at the sites. That is, wherever you require the power generation or the production of the steam, so then the boiler can be movable from one place to the another place, then it is known as the portable boiler. And next one is known as the locomotive boilers, because whenever you are going for any railway engines, so most of the railway engines are using the locomotives, so these are the designed boilers are there in the locomotive engines. The next one is the marine boilers, because as the name indicates is a marine, so it is the marine boilers are used only in ships. Next, according to the position of the boilers, so these are classified into horizontal boiler, vertical boiler, as well as the inclined boiler. The next classification is the position of the furnace. Whether it is firing is taking place internally, then it is known as the internally fired. The example are the Cochrane boiler, Lancashire boiler, etc. And if the firing is taking place outside of the furnace, then it is known as the externally fired boilers. Examples are Babcock Wilcox, as well as Stirling boilers, etc. And the next classification is according to the pressure of the steam generated. So whether it is producing the low pressure, then it is known as the low pressure boilers. So these are able to generate only 15 to 20 bar pressure. So this particular steam is basically used for the process heating applications. The next one, it is known as the medium pressure boilers. That is something above 20 bar. And the range is 20 bar to 80 bar. So in this particular, the medium pressure boilers. So the applications we are able to find in the power generation as well as the process heating. And the higher pressure boilers, it is more than 80 bar pressure, then it is known as the higher pressure boilers. Subcritical boilers, that is here the less than the critical pressure of the steam, that is the 221.2 bar, then it is known as the subcritical. The supercritical means over and above this particular 221.2 bar, then it is known as the supercritical boilers. According to the charge in the furnace, that is the pulverized fuel or supercharged fuel or the fluidized bed combustion boiler, that is it is known as the FBC. So fluidized bed combustion boilers. So what are the basic parts of this particular boiler and what are their functions? So the boiler is basically having the drum. So here is the drum is a very crucial one. So it is basically consisting of the shell and its heads, and similarly the setting is a grate. So on the grate only we are able to pour the coal. That is, the coal is basically burned over this particular the grate surface only. So it's known as the grate over which the fuel will be dumped. So furnace where we are heating. So this particular the steam and the gases are basically generating. So the flue gases are able to generate whenever you are burning the coal, and similarly the flue and heating surface, and stoker, that is a furnace mechanism, and water wall. And similarly the water space and steam space is a feed water, working pressure, economizer. Yeah. Economizer, air preheater, superheater. So these are the devices which are basically used to increase the efficiency. So that is, here in the economizer we are able to heat the feed water with the help of the waste heat flue gases which are leaving through the chimney. So because of which we are able to observe the plant efficiency will be increases because of providing the economizer. And similarly air preheater also, because the atmospheric temperature of the air is basically heated further with the help of the hot flue gases which are leaving through the chimney. So because of which the hot air will be supplied to the boiler. So the heat input to the boiler will be normally reduces, because of which also the efficiency of the thermal power plant will be increases. And similarly the superheater, so always it is desirable to have the superheated steam at the exit of the boiler. So that is, the boiler drum is basically connected to the superheated tubes, so that the steam will be further sent to the superheated tube, so that the superheated steam is basically leaving the boiler and it is entering into the turbine. And what are the basic characteristics of a good boiler? So the boiler should have the maximum steam generation rate with minimum fuel consumption. So that is very, very important one. That is, always the efficiency is nothing but it is the output by is the input. So output should be maximum and input should be minimum. So that is the same principle will be applied to the boiler also. So here the output is nothing but the maximum steam generation rate. So that's why it should have the maximum. And in the denominator we are having the input. The input is nothing but the fuel consumption. So the fuel consumption should be always minimum. So it is exactly to satisfy the efficiency definition, output by input. And it can be started or stopped very quickly. And the cost parameters, initial cost, running cost and maintenance cost should not be very high. So it should be very meager. And similarly its erection time should be less, and the boiler should be reliable one, and it should have the higher rate of the heat transfer, and similarly it should occupy the very, very lesser space, and it should operate and act accordingly the Indian Boiler Regulation Acts. So these are some of the characteristics of a good boiler. And what are the various factors which are affecting while you are selecting a boiler for a given application? So always you have to ensure, that is, what is the steam generation rate of the boiler at a given working pressure. So far we have classified the boilers into the low pressure, medium pressure as well as the high pressure boilers. So for a given application, how much amount of the steam we are able to generate from the boiler at a given working pressure, that idea you should know. So similarly, what type of the fuel we are using and what is the rate of the burning, availability of the fuel and availability of the water, and how much amount of the floor space is occupied by the boiler, and the type of the loading condition is the steady load or fluctuating load conditions. And similarly the cost parameters are also very, very important while you are selecting the boiler for a given application. And now this is very, very important one, that is the differences between the fire tube boiler as well as the water tube boiler. So far we discussed about the working principles of the water tube as well as the fire tube. The same thing is consolidated. So that is, just you go through the salient features of the water tube boilers as well as the fire tube boilers. The important parameter is the water tube boilers are basically having the higher efficiency of the 90% compared to the fire tube boilers, which are having the efficiency is equivalent to only the 75%. Just now I told you that the water tube boilers are basically used in the very, very larger thermal power plants, and here they are used in only in the process industries like textile industries, sugar industries, and the rice industries. Like this, they are using the fire tube boilers. So like this, we are able to classify the fire tube as well as the water tube boilers. So let us deal with the important fire tube boiler is Lancashire boiler. So the Lancashire boiler is, that is horizontal one, and it is a internally fired, is a fire tube boiler, is a natural circulation boiler, and it is a stationary boiler. That is, so far we classified the boilers according to the various points. Now here, whenever you are describing the salient features of any boiler, now you have to remember, so on which basis you classify the boiler. So all these things you should apply, whether it is a horizontal or vertical or inclined boiler, whether it is an internally or externally fired boiler, it is a fire tube boiler or water tube boiler, or whether it is a natural circulation or forced circulation boiler, or whether it is a stationary boiler or is a locomotive boiler or movable boiler. So like this, for every boiler, whenever you are classifying, so just you remember the points on which you classified the boiler, so on which only you have to give the description about each and every boiler. So it is widely used boiler because of reason that is it is producing very good steam generation capacity, but the modern steam pressure which is equivalent to 15 bar. So go to this particular the salient features of the Lancashire boiler here. So I just now I told you that this is known as the grate. So it is the platform on which we are able to pour the coal. So here the coal is basically burned over this particular the grate surface. So the flue gases are basically generated inside this particular the tubes. These are known as the tubes. So inside this particular the tubes we are able to generate the flue gases, so which are surrounded by the water. So all these things are the water. So the hot flue gases are basically giving up its heat to the surrounding the water which is flowing here. So because of which the water will be converted into the steam. It will be steam. So this is known as the steam space, and this is known as the water space. So this particular the steam is basically sent to the turbine, because always here you can see the safety valve and the steam stop valve, because these are the boiler mountings. So the boiler mountings are very essential to run the boiler very safely. So without this particular the boiler mountings, the boiler will not work safely. So for the safety purpose, the boiler mountings, and similarly to improve the performance purpose, the accessories are normally incorporated the over and above this particular the boiler. So similarly here we fitted the pressure gauge, that is how much pressure we are able to generate, and similarly here the water gauge to gauge how much amount of the water, whether it is sufficiently available or not in the water space. So like this the Lancashire boiler is basically works. Now let us go to some previous IES examination questions in this particular the class. So here he has given the match the following. So he has given here the 4 different types of the boilers, and here the classification of the boilers are given. So now you have to answer which one is correct. Basically there is a A, B, C, D. So here the answer is given as the B. So that is B here, 1, 4, 2, 3. So that is the Lancashire boiler. Just now we discussed it is the horizontal straight line fire tube boiler. And Benson boiler, it is the high pressure boiler. Babcock and Wilcox boiler, we discussed that it is a water tube boiler. It is the inclined and straight tube. And similarly here the Stirling boiler. So Stirling boiler is also a water tube boiler, but it is a bent type. So like this you can give the answer will be equivalent to B. And here also the same thing is a match the following. It is a Lancashire boiler, Cornish boiler, Lamont boiler, and a Cochrane boiler. So here only the Lancashire boiler is the common one, but here he has given the 3 different boilers. So similarly here also you can use the same concept. So here the answer is equivalent to A. So the Lancashire boiler, it is a horizontally fired boiler, it is a double fire tube boiler. And similarly Cornish boiler, it is a horizontal single tube boiler. Lamont boiler, it is basically high pressure boiler. Cochrane boiler, it is a vertically multiple fire tube boiler. So the answer will be A. So here also it is a match the following. So the same concept here you apply. So the answer is 3, 2, 1, 4, because the Babcock and Wilcox is example of the water tube boiler. And you know that the Lancashire boiler, it is known as the fire tube boiler. Is a Lamont boiler, it is the forced circulation boiler, and the Cochrane boiler is nothing but it is a vertical boiler. So like this we can classify the boilers, and similarly how can you select a boiler for a given application, and what is the working principle of the Lancashire boiler. So all these things we have discussed in the today's class. So thank you for listening the today's class. Thank you very much.